Welcome, everyone. My name is Teddy Hecht, Marketing Manager at Alango Technologies. I want to sincerely thank each of you for your time. The topic of this talk is TWS headset voice enhancement using bone conduction. The demo presentation will go about 30 minutes, including time for questions at the end. First, I'll present the underlying concepts. Then I'll run the demo so you can experience how OnlyVoice performs in noisy environments. After that, I'll open up the floor to questions, and I'll be inviting our Chief Audio Engineer, Alex Radzishevsky, to answer your questions. At any time during the meeting, you can ask us a question using the chat feature, and we'll get to these questions at the end of the meeting. Today, I'm going to tell you about a state-of-the-art voice processing technology for true wireless earbuds that uses bone conduction microphones for noise-free voice acquisition. First, I'll briefly introduce Alango to you. Alango sound processing technologies improve the quality of voice communication, enhance speech recognition, and make audio more enjoyable. Our mission as a company is to empower your product to deliver a satisfying voice and audio experience to your end user, even in real-world high-noise environments. We're active in many industries. Our key fields of operation have been automotive hands-free and Bluetooth accessories such as headsets, headphones, and earbuds. Why do we need this technology? Today, there's a new normal, and working from home, conference calls, and web meetings have become standard practice for business around the world. Voice communication is as critical as ever before. Even with all the advanced communication tools at our disposal today, like Zoom, Teams, video conferencing, real-time screen sharing, it is the voice quality built into these platforms that determines the experience. High-quality voice communication starts on the front end with devices and technologies for clear voice acquisition and pre-processing. Voice transmit quality has gone from being an afterthought on Bluetooth earphones to a mainstream, sought-after feature that can give a competitive edge to the brand. I'm sure that many of you have a go-to headset or device that you use for calls when voice quality is important. On the other hand, you might have certain devices or headsets that you avoid using for calls because of the poor voice pickup. Today's consumers expect their earbuds to offer a premium voice experience. They expect their voice to be heard clearly by the other side and understood by speech recognition engines, no matter where they are speaking from. This picture, by the way, came from YouTube, where it's easy to find voice performance comparisons for popular devices. In fact, we made our own video comparison, and it's up on YouTube and our website if you'd like to watch it and listen to the comparison, where we compare our OnlyVoice prototype with the AirPods Pro in terms of voice quality across different noise scenarios. I'm not going to show it here, but I'll share the links with you at the end of the session. Before we talk about sensor fusion and bone conduction, what about beamforming? When dual mic beamforming was first introduced to the headset form factor, it brought a significant voice quality improvement over single mic. For the end-fire beamforming configuration, two omnidirectional mics are placed a small distance apart, sitting on an axis that points towards the user's mouth. Because of the spacing, sound waves arriving at the array hit the two mics with slight variations in timing that depend on the direction of arrival. The beamforming algorithm leverages this time difference in order to preserve on-axis sounds, such as the voice signal that comes from my mouth, while sounds coming from other directions are attenuated. Now, in many cases, dual mic is perfectly capable of providing excellent call quality, but the technology has inherent limitations. After perfecting this technology over the years at Alango, we've more or less reached the performance limit of beamforming. We can improve it here or there, but we don't expect to see any game-changing improvements in dual mic beamforming. In certain very challenging noise scenarios, beamforming is not enough. For example, in high wind noise or very high noise scenarios can create a low or negative SNR that limits the effectiveness of the beamformer. Also, while the beamformer is good at rejecting distractor speech, in other words, other competing talkers around me who aren't me, distractor speech, if it comes from the side of me or the back of me, Voices coming from the front are on the axis of preservation and are not attenuated by the beamformer. Let's talk about bone conduction mics and why they are so useful for TWS. As opposed to the dual mics, which pick up external voice signal transmitted by air conduction, the bone conduction mic picks up an internal signal transmitted by skull vibrations. The internal signal is effectively isolated from external noise and wind, allowing for voice pickup in situations where external beamforming alone is unusable. Another benefit of bone conduction voice processing when compared to the signal acquired via in-ear mic, in other words, an internal in-ear microphone, is that the bone conduction mic does not require a complete seal of the ear in order to work properly. It only needs to make good physical contact. With in-ear mic processing, on the other hand, the signal is spoiled if the earbud sits loosely, and it doesn't work in open-fit designs. One of the challenges of using bone conduction for voice pickup is the relatively low bandwidth of the internal voice signal. While there is some variation between sensors from different manufacturers, higher bandwidth can come at the expense of a higher noise floor. In general, we're talking about 1.5 kilohertz of bandwidth on the internal signal. In a moment, I'm going to switch the output of the demo kit. By the way, this whole time you've been hearing the output of the OnlyVoice algorithm on the demo kit. I'm going to switch it to raw sensor output so you can hear what just the sensor sounds like.
I'm speaking to you with raw sensor output enabled. You will probably have difficulty understanding me.
Check my connection.
Check the profile that you use.
Okay.
Single mic, dual mic?
No, it's a bad sound. It was a bad sound because I switched to raw sensor. My chief audio engineer came in here and told me the sound was bad. But that was intentional because I wanted you to hear what the output is like from the raw sensor. It's not very useful by itself. So the challenge is how and when to mix it with the external signal from the beamformer. The key component of OnlyVoice processing that combines the internal and external voice signals into a single enhanced output is the intelligent mixer. OnlyVoice uses spectral mixing to combine the signals, and the combination depends on the spectrum of the noise and the relative SNR of each of the audio signals. In low noise environments, for example, or no noise, only the beamforming might be used while the internal sensor is turned off and not used to save power. In medium or high noise scenarios, the signals are combined using spectral mixing and processed into a single output. And in very high noise or extremely windy scenarios where the external signal is completely unusable, the sensor signal will be processed by itself and can provide a usable output. The OnlyVoice package includes all of the required processing blocks for voice communication, including, besides for the intelligent mixer, acoustic echo cancellation, noise suppression, and gains management, as well as beamforming processing. Now that I've finished introducing the technology, I want to give you the opportunity to experience it live in different and challenging noise conditions. To do that, I'm going to simulate noise environments using two M-Audio monitor speakers, which you'll see in a moment when I switch back to video. I'm going to play noises over the speakers and then speak to you using the demo headset, which you can see pictured here, while I turn the OnlyVoice processing on and off so that you can hear the difference. What you've been hearing since the start of this webinar is my voice picked up by the microphones and internal sensor of the demo headset and processed by OnlyVoice. The processing is done on this ST Microelectronics Discovery board running on an ARM M4 demo processor. We also have a demo kit available running OnlyVoice on a Qualcomm QCC5141 evaluation board, and we would be happy to work with you to port it to other platforms. that concludes the presentation portion. I'm now going to run the audio demo. Again, what you've been hearing is the output of the OnlyVoice demo kit. I have the ability to switch between different profiles. Right now, there is it's running the full processing using the external mics and the internal sensor. You can see to my sides that I have two monitor speakers, which are going to be playing noise. That I have some noise files on this MP3 player. During the playback of the noise, I'm going to use this SPL meter to show you just how loud it is. And just so you can hear, I'm going to switch to raw mic. You should now hear the raw microphone output. Again, the room is relatively quiet. This is the raw microphone output, single mic coming from the external sensor. I'm going to scratch it so you can hear that it actually is coming through. And I'm going to load up one of the noise files. Okay, the first noise that I'm playing for you is simulating a train environment. Let's measure the noise. What's the noise level near my headset? I'll use this SPL meter so you can see that it's working. It's about 88 dB SPL. What you hear now is the raw mic signal. In a moment, I'm going to switch to the dual mic output. You should now hear my voice processed using VCP dual microphone. This is dual mic beamforming without the internal sensor. The noise reduction is pretty good, but we can do even better. Again, just so you know that I'm processing audio through the headset. You can hear me tapping on the headset. And Frank, this is wow on our dual mic. We haven't even gotten to the OnlyVoice yet. Let me now show you the output of the full processing, including all three audio sensors. You should now hear me speaking through the full processing. This is OnlyVoice using both the external beamforming mics and the internal sensor. My voice should be coming in very clearly and with great noise attenuation. Again, I'll switch back to the raw microphone for a second. Now you're hearing the raw mic signal. Again, this is about 88 dB SPL noise. And I'll switch back to the full processing. Now you hear the full OnlyVoice processing. Okay, now I'm going to switch back to raw microphone and cue up a different noise simulation. What you hear now is the sound as if I was in an airplane. This is aircraft noise. Again, you're hearing the raw microphone signal. Let's use the SPL meter to measure the noise near my ear. The sound pressure level near my ear is approximately 89 dB SPL. You're hearing the raw mic signal. I've now switched to the dual mic output. This is the dual mic beamforming output. My voice should be pretty clear. Should be doing a pretty good job of removing the noise, but we can do even better than that. You're now hearing the output of the OnlyVoice algorithm using both the external beamforming mics and incorporating the internal sensor. my voice should be coming through very clearly with very little noise. Again, this is the OnlyVoice output. The noise is still pretty loud. That's 89.6 measured on the SPL meter. But OnlyVoice is doing a great job at effectively removing most and all of the noise. Okay, let's switch. I've now switched back to raw mic, and I'm going to do the final noise simulation here. I'm now speaking to you from a noisy cafeteria. There's a lot of people speaking around me, a lot of voices competing with mine. Let's measure the sound pressure level at the headset. It's approximately 85 dB SPL. Again, this is the raw signal. Now I'm going to switch to dual mic. What you hear now is the output of the dual mic beamforming. Again, to confirm, I'm scratching the mic so you can hear where the audio is coming from. It's doing a good job of removing the noise, but not without a small amount of distortion, because this is an extremely loud environment, and it's pushing the limits of the beamforming technology. Again, this is a pretty loud simulation. Now I'll switch to the OnlyVoice algorithm. You're now hearing the OnlyVoice processed output using both the external beamforming mics and the internal sensor. In this profile, with this processing, it does a great job of removing the noise in a way that the beamformer struggles with at this type of volume and in this scenario. Again, I'll switch back to the raw mic for comparison. You're now hearing the raw mic output. This is the raw microphone single mic output. And now you're hearing the output of the OnlyVoice algorithm. This is the full processing, which is very effectively preserving my voice, but not the noise or the other voices coming from around here. At this point, I'm going to invite the chief engineer, chief audio engineer, Alex Radzishevsky, to join us to answer some questions. I'm also going to switch from talking to you through the headset to using a speakerphone so both of us can hear at the same time.
Hi everyone. Thank you, Teddy, for the great demonstration. My name is Alex Radzishevsky. I'm Director of Product Development and Chief Audio Engineer. So if you have any questions, I will be happy to address them. Please raise your hand and Teddy will pick up your question.
You can also unmute your microphone and ask if you wish. To answer the question earlier about making a recording available, yes, that is our intention, assuming that all of the technical aspects of the recording work properly. We will be making the recording available for you to view again later.
A couple of notes from my side regarding this technology. Like Teddy said, this technology is available on a variety of platforms, DSP platforms, including Qualcomm QCC platform, and this board is ARM M4, and we also support and we have optimized code for other popular platforms such as Hi-Fi and many others. So this technology is immediately available for deployment in your products.
We have a question. How much of a bandwidth do you need from the bone conduction sensor? What's the minimum and what is the maximum?
Thank you for this question. Well, first of all, this technology is pretty much universal, and I would start from saying that it does not put any specific requirements on strict requirements on the capabilities of the sensor. Of course, the better sensor you apply, the better SNR it gets on picking up the user's voice, the vibration from user's voice, and the wider bandwidth it can provide, the better results, the better enhancement you will have, of course. And this technology has been tested with different sensors, not only vibration sensor and not only single axis sensors, but also with triaxial sensors and also with in-ear microphones that are located inside ear canal. And it does very good job. The bandwidth, the typical bandwidth that can be achieved in uh, let's say a finalized product within the cabinet of this, plastics and or the cabinet is below 1 kilohertz usually. So we know sensors that can pick up vibrations beyond that, but the loose sensors. But usually, when such a sensor is applied in a product, the bandwidth is about 1 kilohertz and below. It also depends on basically the contact, the physical contact of the device with the specific user. So the fitting may differ from person to person, and so the bandwidths also. So this technology is very is capable of dealing with the changing bandwidth dynamically, depending on the contact, the physical contact in the product, on a specific user. I hope it addresses this question.
We have another question. Is OnlyVoice only for in-ear headphones, or can it be used for over-ear or on-ear headphones also?
Thank you again for this question as well. We did experiments with over-the-head headphones, and we tried to apply a vibration sensor in an ugly way, just by gluing it out on the external surface of the headphone, of the ear cup, and we saw it is a workable solution. It helps it pick up enough vibration even in this kind of design. So of course we don't have many evidences, but according to our experience in-house, just this simple experiment have shown very good potential. Regarding in-ear designs, so there are also different kinds of such designs. Variety of them provide very good vibration picked up by the sensor.
Dana asks, hi Alex, what process is used to tune this algorithm? I am familiar with the audio logging requirements for VCP. Do you use the same tool and same method for collecting logs with the addition of the bone sensor? If I start with a good VCP tuning, is it fairly easy to then take these params over to OnlyVoice and tune with the addition of the bone mic?
Dana, absolutely, you are correct. Basically, OnlyVoice technology is kind of a superstructure on top of VCP. So whenever you have a properly tuned VCP algorithm utilizing dual microphone beamforming, or even one microphone, which is of course a rare case today, definitely the same tuning applies to OnlyVoice. And basically OnlyVoice technology utilizes, let's say internally, it utilizes kind of two processing objects. One for the external acoustic microphones, based on this exactly, on the same VCP, where you can reuse this tuning. And another one is used for the vibration sensor, which needs to be tuned separately. It's quite easy to do. It is the whole process is based on logs that you mentioned. So it's a different. It's basically a raw audio capture of all PCM signals coming in and out of the algorithm. This information is fully enough for us to do the tuning even offline. And in the end of this process, it may be an iterative process. So you can, you can take first a log just in not noisy conditions, just to check gains and levels and the equalization. And after a few iterations, you can come up with finalized tuning. And again, the VCP tuning that you do for dual mic external acoustic microphones can be reused.
Robert asks, will OnlyVoice improve the performance for voice assistant as well as intelligibility to a human?
Well, definitely. Definitely the OnlyVoice processing, we have no doubts that it helps to voice assistants, because in noisy conditions, even the best beamforming algorithms may provide a bit distorted sound, and which definitely affects the performance of the ASR, automatic speech recognition engine, and the ability to understand you. So definitely this technology helps by cleaning out the most important um, frequencies for the intelligibility of speech, the lowest frequency part, bandwidth up to 1 kilohertz. So it contains the most important information for ASR engines.
Can the algorithm handle data from a triaxial sensor, or are you expecting a single channel sensor?
Yes, the algorithm can handle signals from triaxial sensors. So this technology can be applied to all types of sensors, including single axis, triple axis sensors, and in-ear microphones. So that's the answer.
Does Alango's current technology also look into body noise cancellation?
I'm not sure what you mean by body noise cancellation.
As a part of ANC.
Sorry, I may misunderstand your question. What means
Body noise cancellation.
If you can
Hi,
elaborate.
Alex. Can you hear me?
Yes, please.
Yes. Yeah. So by this, I mean, so normally you have active noise cancellation, which tries to get rid of all the background noise. But when you have subtle head movements, for example, or your headphones just brushes your shoulder or something, or you just like clasp your teeth, does it also take that into account and is able to cancel that?
It's a very good question. Thank you for asking it. Basically, you are absolutely right that the vibration sensor may not only pick up the user's voice, but also all these mechanical things, such as when you move your head, body, or if you chew a crunchy stuff, let's say, and it creates a lot of noise, or I don't know, disturbing sounds on the vibration sensor. And OnlyVoice technology implements special means to treat those parasitic sounds and to filter them out. So we took special measures in order to filter them out and basically exclude them from the enhanced sound.
So if there are no additional questions, I want to thank everyone very much for sharing your time with us. I hope that this demonstration gave you a good idea of the level of noise cancellation and voice quality that the OnlyVoice algorithm is capable of. If you have additional questions, we are available by contact by email. You can learn more on our website, alango.com. Thanks to everyone, and look forward to an email afterwards where I make available a recording, again, if everything technically worked out on that. Thanks, everyone.
Thank you, everyone. Thank you for participating.